So it's 6 o'clock, and we will wait for 10 more minutes, and then I will start the presentation once all people joins. Hello everyone. I will just wait for 10 more minutes, and we'll start the presentation at 6:10.
That's fine. Okay.
So, can you all see the slides? I've shared the slides.
Yes, sir.
Okay. Some people are coming now also, so I will wait for 5 more minutes and then I will start the presentation.
Sir, can it be possible to share this presentation?
Uh, this presentation will be uploaded on the YouTube. This whole video will be uploaded on YouTube, so you can watch it anytime.
Okay, sir.
Welcome everyone. Today I will be giving you an introductory class and will help you to solve the assignment of this year by providing you the solutions and how and theories of the solutions to the 2021 assignment. So this NPTEL program is on the topic of biomass conversion and biorefinery, and the course coordinator of this subject is Professor Kaustuba Mohanty from the Department of Chemical Engineering, IIT Guwahati. You might have been seeing his videos in this NPTEL program. And I am Arihant Ahuja. Sorry, I am Arihant Ahuja, a PhD scholar in the Department of Paper Technology, IIT Roorkee, and I will be your TA in this program. I'm currently working under the guidance of Professor Vibhor Kumar Rastogi, who is in Department of Paper Technology, IIT Roorkee. So, before starting, I would like to tell you something about me that I am I have done my BTech in chemical engineering from Bipin Tripathi Kumaon Institute of Technology. in Dorat, which is in Uttarakhand, and then I did my MTech in packaging technology from IIT Roorkee, and later I did I am currently doing PhD in the paper technology department of IIT Roorkee, and I am currently receiving Prime Minister Research Fellowship from 2021 for the project of paper-based value-added products, which I am currently pursuing in the PhD program. So let's start with the assignment one of 2021. If anybody have any question, you can always comment in the message box, and after the lectures, I will be answering the your queries. And to make it more interactive, I will be asking you questions during the presentation. So please, if you don't know the answer, just you can guess it anything, and it doesn't. And don't think that if you don't know the answer, you will not tell it, but you just say whatever you want to. So the first question of assignment 1 in 2021 was, in which year global total primary energy demand expected to plateau despite strong population expansion and economic growth? Can you all see the question? Anyone? Parapudi, Dinesh, Shreya, Sanjay? Anyone who can answer this? In which year a global total primary energy demand is expected to plateau despite strong population expansion and economic growth? So, first of all, what does this mean? What does this mean that the energy demand may plateau? So the thing is, whenever we look for a graph of energy demand, the energy increases over a period of time and then exponentially increase. But after a time, it makes a pivot point and then decrease. So during this part, this is called as plateau. So what is the expected year when the energy demand will plateau? To answer, the answer is 2035, year 2035. So if we see the graph of energy demand, the industrialization of Western economics and the energy was mostly of biomass in the era of 1850 to 900. It was very low. The energy demand was very low, and mostly it was biomass based energy. But then, with the advent of technology, the global industries expanded into the transport system, which was fueled by coal coal and oil. So this coal and oil helped in increasing the energy, and the dependence on biomass was reduced, and the the energy increase was seen from 1900 to 1950. But then the standard of living increased. People have fridge at home, air conditioner, washing machine, and every type of utensils we if we need to energy to use it, and therefore the energy demand increased exponentially, which I showed you in here. And this exponential growth was seen up to 2000. And then after the rapid industrialization in China, the expansion there was increase in energy expansion, but at a slower rate, and which we expect it to plateau till 2035. And after 35 it may be constant. So this is based on some surveys and mathematical models that despite the strong increase in population and economic growth, the energy demand might not be that much. After 2035 we may reach a pivot point at that time. But what about the renewable energy? and fossil fuel energy. Will renewable be more used in the future? Yes, as we have seen that fossil fuels generate more CO2, and it it emit more carbon than the other. It is not environmental friendly, so that we are moving towards the renewable energy from the fossil fuel energy. So we expect this plateau at 2035 due to that only. So after that 2035, we expect the fossil fuel demand will go down, and the renewable will make up that the demand. So the renewable energy will be making up that demand, and for that there are many ways to achieve it. For example, wind, solar, and hydro. You have might read about it, but there's another gem hidden behind it, and that is biomass energy. So we expect that the biomass will play a good role, and which was used in the 1850 to 900 era will come again after the 2035. We will again be dependent upon the biomass so that we could utilize the waste and meet the and keep the economy under the closed loop. So the second question is, which one is the largest in volume production of global liquid biofuel? So what do you think is the highest producer of the liquid biofuel, or which country is producing it, or uh, what is that liquid biofuel which is which is in the large production? Any guesses? Anyone? No guesses? No. Someone has said coal. No, actually coal is not biofuel. Yes, ethanol. Ethanol is a biofuel. So let's check the answer. Bioethanol. So yes, Sanjay was correct. Ethanol is the largest uh, produced global liquid biofuel, and since it is produced biologically, so it's known as bioethanol. And US is the largest producer of bioethanol, while EU is the largest producer of biodiesel. Both are at the largest fuel is bioethanol worldwide, and at second it is biodiesel. But bioethanol is produced majorly by US, and biodiesel is produced majorly by EU countries. So bioethanol is an alcohol. But what is bioethanol? Is it different from the ethanol which is made industrially? On chemical basis, if we see the chemical structure, both are same. The normal chemical ethanol and bioethanol both are chemically same. Just the difference is in the production steps. Bioethanol, particularly, is an alcohol made by fermentation, mostly from carbohydrates, produced in or starch crops, such as maize, sugarcane, or sweet sorghum. So, everything which is carbohydrate, particularly, can produce bioethanol just by fermentation. The most common example is alcohol, which we drink, such as whiskey or wine, these types of things. These are also alcohol and made by fermentation of some crops. So, bioethanol can be produced from maize, sugarcane, or sweet, particularly cellulose biomass. Derived from non food sources such as trees and grass, is also being developed as a feedstock for ethanol solution. So, there are two types of sources which we have read now. One is edible, and second non-edible. The edible sources are particularly sugar, maize, or starch, and one is non-edible. Non-edible are any kind of trees, any kind of leaf which we cannot eat because our stomach cannot digest it. So both can produce the ethanol, bioethanol, because both have one common thing, and that is carbohydrate. So carbohydrate is a common thing which needs to make bioethanol. This ethanol can be used as a fuel for vehicle in its pure form, but it is technically not used as impure and is rather mixed with gasoline to improve the vehicle emissions. You might also have heard that India is particularly working on ethanol blending with petroleum products, and this the it, but the ethanol demand of India is very much high. So to overcome this, many big PSUs have collaborated with small and micro industries so that they could make bioethanol from the crops such as trees, grasses, or waste products. So, if we utilize that waste product instead of sugar, because sugar is costly, why should we make from sugarcane? We should utilize waste. So, when we utilize the waste and produce the ethanol from it, it will also help in reducing the waste. This concept is also known as waste valorization. That we Valorization means to make something economically, to make something good of economic value, which does not have economic value, such as waste. So to produce something from waste is known as waste valorization. So many companies in India, and there are many projects in India which are happening, which are utilizing the waste of different states of India's, and producing bioethanol so that it can be used as a at now to use it as a blending material with petroleum. But in future, we might attain 100% bioethanol based fuel also. So let's move on to third question. Highest use of biomass in electricity only plants in continents in 2017. So, which continent do you think has the highest use of biomass? There are seven continents: Africa, Asia, North America, South America, Europe, Antarctica. So, what do you think? Any guess? I will give you a hint. The highest populated, or the highest area, with the continent which is highest area, might be the answer, because more resources, more develop, or yes. So Asia. So Asia is the largest. Asia is the highest. Is the continent which use the highest amount of biomass to produce electricity. So some facts about it. Asian continent has the highest total energy supply globally, along with the highest renewable energy supply. So yes, we produce total energy also highest, and we also produce the highest renewable energy supply, both kinds of electricity. But in terms of renewables, if we particularly go for renewable, not biomass, only renewable, then it African continent is the largest producer. But there's a difference between renewable and biomass. Renewable involves wind, hydro, solar. But biomass does not involve these. These are particularly biomass are particularly based on waste of insect, plants, or other things. So when we see the renewables, then Africa has the highest. When we see the biomass, Asia has the highest. And almost half of all the energy supply in Africa is via renewable energy sources. It's a very good achievement for African countries that they are already using 50%, more than 50% of their energy is from renewable rather from fossil fuels. And if we come to Europe, Europe has only 10.3% share in of renewable in its energy supply, although it produces highest amount of biodiesel. but it is still dependent upon the mostly fossil fuels or nuclear energy. So these were some facts about the energy consumption or energy supply by different continents. And if you want to go into more deep, that how much they produce, so this table provides a data based on the 2014. The question was originally on 2017, but nearly same um, energy consumption can be seen in 2014 also. So we can clearly see that Africa has highest renewable consumption, 49.6%, nearly 50%, and the lowest was Europe, 10.3%. And Europe is mostly dependent upon the natural gas. Natural gas is very much used there. Europe also, the climate, due to the climate condition, most of the part of Europe is cold. So to warm their houses, they use natural gas. You might have seen in many TV series or any movies that they use gas heaters in their room, and so that is based on natural gas. So Europe mostly uses natural gases for there. And for Asia, if we see, Asia particularly uses 70. Asia is particularly uses oil and coal for their energy demand. Oil and coal both. So that's why it is very a big problem for Asian countries also, that we produce most of the carbon emissions, because coal is the oldest fossil which we are using, but it is not considered as the greenest. It is considered as it, because it produces more CO2 than the other when we compare with the other energy. So next question is based on the carbon emissions. So carbon emissions are projected to decline. So we have predict that the carbon emissions will decline. It will decline, but due to this decline can be achieved only by one thing. We can decrease one demand. So what can be it be? So I will give you some options. First is coal, second is natural gas, third is nuclear, or fourth is other. What do you think if we reduce our demand, coal demand, natural gas demand, nuclear, or any other demand, then we can have lower carbon emissions? Any guess? Okay, someone has said crude oil. Okay, yes, we also use a vast amount of crude oil. Yes, it can be answer. And anyone want to guess? Somebody has said coal and natural gas. Okay. So in this case, Sanjay is right. The answer is coal. You see, the thing with coal is we are using it from very past years. Coal is with us from the industrial revolution, and it is still being used. We have very much coal mines and we are much dependent upon the coal. But the thing with coal is that it produces a lot of carbon, or we can say the coal industry is uh, not environmental friendly. It produces more carbon when we combined all these other energies such as natural gas or nuclear energy. So I will give you the data later. I have saved a graph for this. I will share that data in the later slides. So coal energy has the highest carbon footprint of all the energy types. It has the highest carbon footprint, and it produces 820 grams of carbon dioxide on life cycle basis. So what is life cycle basis? When we whenever you will see this term life cycle basis, it generally means that छोटे से बड़े तक, मतलब from the start to the end, what amount of carbon dioxide is it producing. So everything is considered, even the transportation. The If we are transporting something, if you are transporting fuel from point A to point B, the fuel used for that transportation will also be go into the account. So this is known as life cycle basis. So coal emits 820 grams of CO2 on life cycle basis per kilowatt, if it and it directly contributes to the climate change. Oh, sorry. It directly contributes to the climate change and has various negative environmental effects due to the highest release of carbon dioxide. So, this is the reason that coal is also known as dirty energy. And coal is the main global fuel source with vast environmental implications. Coal are of particularly three types. One is lignite. It has the highest energy content of all types. There are two more different types of coal, but lignite has it has the lowest energy content of all types, lowest, due to the high moisture content, which is around 25 to 35% of. It is used mainly to generate electricity in account 8% of the total coal mines. So lignite is the lowest energy content of all the coals, and it accounts only 8% of the total energy. Second is subbituminous coal. So it has a lower heating value than bituminous coal and contains 35 to 45% carbon, and it accounts for 44% of the total US coal production. And the last is bituminous, which is has the highest carbon content of 45 to 86%, and it is known as best variety of coal for producing the energy. So it accounts for total 48% of the total US coal production. It is also used to generate electricity and act as a fuel and raw material for making cooking coal or in the iron steel industry. So, but majorly these three types are the types of coal, and we use mostly bituminous coal in the for the production of electricity. Which source is the highest contributor of CO2 emission in the world? This is a very easy answer, as I've given previously also. We have discussed in the previous slides. It's again coal. So, as we have discussed earlier, that coal is considered as a dirty energy because of highest carbon footprint, and it produces 820 grams of CO2 on life cycle basis. This is the graph which I was telling that we will be discussing it later. In this shows the average CO2 produced by every kind of energy over its life cycle. So coal, sorry, coal produces at the highest 820 gram of CO2 equivalent per kilowatt hour, and at the second is natural gas, 490. I will be telling about this biomass later. And then we have solar. When we go towards the renewable have the lowest CO2 emissions, such as solar solar energy or geothermal, hydropower, wind, and nuclear also. Nuclear does not emit much carbon, as basically it is based on the chemical reactions in the elements. So when we talk about the biomass is particularly at the third number. First is coal, second is natural gas, and third is biomass in producing CO2. But the problem with biomass is that to produce energy further technologies, and we will be discussing this in later on in later chapters. But for now, I want to just show you that the coal produces highest CO2, and then it is natural gas. Wait a minute. So there was a call. So okay. So next question. In following list, which is not considered as renewable energy source? Yes, this is a good. This might be some mind-boggling to some people. And so, any guesses? Is it wind, hydro, solar, or natural gas? Okay, so somebody has said natural gas. Yes. So the answer is yes. Natural gas is not considered as renewable energy. When we read the term natural, yes, it always comes to mind that it comes from natural sources, so it might be renewable, but it is not. Natural gas, on the other hand, is produced from fossil fuels. I will explain here. So, natural gas, also called fossil gas or simply gas, is naturally occurring mixture of gaseous hydrocarbon consisting primarily methane, in addition to various smaller amount of other higher alkanes. So basically, when we see the when we go into the chemistry, natural gas is made up of methane and higher alkanes, but it is produced from fossil fuels with and it occurs naturally but due to fossil fuels. So also it contains very low traces of CO2, nitrogen, hydrogen sulfide, and helium, but they are at very low percentage. It is also odorless and colorless. It doesn't have any odor. Many people think that natural gas has some kind of odor. No, it does not contain any odor. Rather, some type of chemical is inserted in the is mixed with the natural gas so that we can smell it. So we can smell the leakage of the natural gas from if it's leaking from anywhere or not. So a sulfur-like smell, also known as rotor-X smell, comes when we see the leakage of natural gas. That is due to the mixing of mercaptan. Mercaptan is a compound which is mixed with natural gas so that we can smell it or detect the leakage of it. It doesn't have any smell, but we mix mercaptan for this purpose. Natural gas is a fossil fuel and non-renewable resource that is formed when layers of organic matter decomposes. Layers of organic matter decomposes under anaerobic condition and are subject to intense heat and pressure underground over millions of years. So, the term this over millions of years. Do, this is the process to make natural gas. That's why it is known as fossil fuel because it is made up of organic matter. Yes, it is made up of organic matter, but it is made over the millions of years, and it also produces more CO2. It produces CO2 at the second highest after the coal. So it's also not considered as a good source of electricity, but better than coal, but not better, not a good source. Most of the Europe uses natural gas for heating their homes or households during the winters or snowfalls. The energy that the decayed organisms originally obtained from the sun via photosynthesis is stored as chemical energy within the molecules of methane and other hydrocarbons. So we can say that it is not a renewable energy source. It's a fossil fuel gas that takes millions of years to form. There's limited amount of it on Earth right now, and when it's gone, we can't produce it anymore because it takes a lot of time. So we should not be dependent upon natural gas also for our energy demand. So, and it produces greenhouse gases, as I've said earlier, that it produces mm, less CO2, but still it is highest 720 gram of CO2 when we compared with coal. But it produces a lot of greenhouse gas emission when burned and contributes to global warming. It's cleaner than coal or oil, so using it to replace them is good for environment, but still not better. So let's come to seventh question. In the following list, which is not considered as clean energy source? Coal, hydro, solar, wind. So I guess you all can answer this question very easily. Hydro, solar, wind are renewables, and we have discussed it previously that coal is not a clean energy source. It is also considered as dirty energy. Yes, the answer is coal. Okay, so the eighth question. Which one is highest world solar photovoltaic electricity production from 2005 to 2017 by a region? So, which region produces more solar photovoltaic electricity? China, OECD, Africa, or non OECD Asian countries? Any guess? Any type of guess? So people have said OECD. Yes, that's the correct answer. So what does OECD stands for? It stands for Organization for Economic Cooperation and Development. As of May 2021, there are 38 members of the OECD. 38 countries are a part of this. So yes, collectively they will produce more photovoltaic electricity when we compare to China alone or Africa or non-OECD Asian countries. Now let's move on to ninth question. Which source is the world's highest electricity generation from 1971 to 2017? Is it nuclear, hydro, natural gas, or coal? Any guess? Which produces highest electricity generation? Nuclear from the era of 1971 to 2017. So the answers are coming. Yes, one has said natural gas, another has hydro, coal, hydro. So I'm seeing very much hydro in the answers, and two people have said coal. Well, hydro is not the correct answer. It is coal. The particularly I've mentioned here 1971. 1971 was the start of the industrialization, and industrialization needed more energy. So coal was responsible for the industrialization revolution globally, and it was done with the help of coal. If we didn't had coal in that time, we might not be so much advanced here. But it was the dirtiest energy. We didn't knew it that time. And 10th question: which sector is the world's highest total final consumption of natural gas from 1971 to 2017. So, what sector might have consumed the highest natural gas from 1971 to 2017? But this question is on natural gas, not on coal. So, was it transport, residential, industrial, or commercial and public services? Any guess? Many have said residential. Yes, residential was particularly used, is being particularly used by European countries, but it is not used by any other country because natural gas is not available for it, for the residential for other countries, for other continents as well. So residential is not the correct answer. It is industrial. Coal and natural gas, and combined with crude oil. These three fossil fuel were responsible for the highest industrial, transport, and residential services during from the 1971 to 2017. So, if you see the graph, this graph is more latest. It's a 2017 graph, not the total from 1970 to 2017. But still, natural gas is used for industrial demand, 37%, and natural gas is used for residential demand also, but only for European countries. But it's used in so much quantity that residential is at the second point. So yes, those who have said residential as the answer are also somewhat correct because residential is at the second most demanded sector for the natural gas. So do you have any questions regarding the past questionnaire? Because from now on I will be discussing on the common concepts of biomass conversion and biorefinery. So before going it, I would like to ask you that if you have any question regarding the previous questions or any other query, you may please ask in the chat box. So I guess no one has any doubt. So let's move on to the common concepts. So fossil fuel consumption pattern worldwide. If we see that, this I'm showing you because uh, I want to tell you that why biomass is being explored, why there's a need of exploration for biomass to replace the conventional fossil fuel. So fossil fuel consumption, if we see from the 1800 to 2010, then we have seen that earlier also that there was an exponential increase during the industrialization. So the demand for energy has increased a lot. Coal was the highest till the 1970s. This point, coal was used as the highest producer of electricity, but then crude oil came and it crossed the production of coal, and now we have the highest electricity production, highest electricity, or not electricity, particularly energy production is done by crude oil. We are doing many most of the things which we rely on is based on transportation on the supply chain, and everything involves a part of crude oil in or any other way. So Now the crude oil consumption is highest, and at second we have coal, and at third it is natural gas. This consumption pattern is for whole world. So, but when we particularly see for the USA and consider all the energy consumption patterns, we see that the coal demand has decreased from 1970 a lot, and they are more dependent upon the natural gas. For US, natural gas is the second most highest used energy resource after petroleum or crude oil. So at first it's petroleum, at second we have natural gas. And they have reduced the usage of coal drastically near 2017, no, 2015. They are not dependent much on coal because coal was considered as dirty energy. Natural gas is also not good energy because it also produces carbon, but it is still better than coal. So they are more dependent upon petroleum and natural gas rather than coal. Also, they have in the 1970, nuclear was used much in the USA, which helped them to maintain the carbon emissions because nuclear energy don't produces CO2 but very minimal. And we can see that biomass was the main energy in the 1850s. It was the highest used energy sources, but it was replaced by petroleum and natural gas. But now we can see that it is again increasing. So biomass, renewable, and hydro, they are very much lower but increasing at a slow rate. And in future, to achieve the sustainability goals by different countries, these energy are the future energy. We are at a very low point where the energy demand is less because we also don't have that much resources in technology. But after a pivot point, these renewable and biomass energy will also exponentially grow in further future. So what is biomass energy? Biomass and energy produced from it. So biomass is the fuel developed from organic matter, waste of living organisms like plant waste, animal waste, forest waste, and municipal waste. So any kind of waste, you can. But what this definition means is any kind of waste you can use, but it produces some kind of energy. So in but if we talk in biological terms, biomass refers to the organic plant matter which is converted into fuel and used as a energy source. Biomass, and how can we convert it into energy? Biomass is converted to energy through various processes, including direct consumption, burning to produce heat. We can either directly burn it to produce heat, or we can do some thermochemical conversions to produce solid gases or liquid fuels from it. So either we can burn the carbohydrates which we have discussed earlier, that we can burn any kind of leaf, sugar, biomass, any kind of thing, just burn it so we can produce, or produce some kind of fuel out of it, such as bioethanol, biodiesel. So those are known as liquid fuels. We can also produce solid and gaseous fuels via some thermomechanical conversion process. This will help in lowering the energy demand, which help which will also reduce the CO2 which was used to fire the biomass fuels. Chemical we can also do chemical conversion to produce liquid fuel as we are doing for bioethanol and biodiesel. And apart from mechanical chemical, we can also go for biological conversions to produce liquid and gaseous fuels. So these are the major uh, ways in which we can convert, which in which we can produce energy from the biomass. These will be discussed later on in further chapters. And so what again, we if we see types of biomass for energy, we can either utilize woods, crops and agriculture residues. Like I've said, that you can use cellulose. Cellulose is a primary component of any kind of tree, any kind of wood, or non-wood, any type of crop. Any, if you see any crop, any wood, stem, leaf, fruit, everything has cellulose. So, and it is a carbohydrate. So carbohydrates in cellulose can be used to produce energy. Similarly, crops or vegetable oils and animal fats, even trash or garbage, you can burn it. Or we can also use we can also burn it in vacuum to produce uh, pyrolysis gas. And sewage waste or animal manure. Animal manure was, we have seen in India very much, that we also uses fuel in village area. And but now this is also being explored as a future potential for good energy source. So from now, as you have to read and seen the questions, so we can see that what might be the difference between the biomass energy and fossil fuel. So biofuel is a fuel produced from living matter. Biofuel is a fuel which is produced from living matter, plants, animal, or any other thing. And fossil fuel is naturally occurring fuel from geological process, which happens over millions of years. So the thing about biofuel is it is obtained from renewable sources. Fossil fuels are not obtained from renewable sources. Biofuels biofuels provide a low amount of energy per unit biomass. It has lower energy, and this is the major disadvantage of biomass right now we have. And fossil fuels provide higher amount of energy when compared to biomass. But then why we are going towards the biomass if it produces less energy? Because it produces less pollution, so it is more sustainable. And when we consider the fossil fuel, it is responsible for environmental pollution a lot, plus global warming. It emits a low amount of unfavorable gases when burned. So this is also again a plus point for biomass. It produces low amount of unfavorable gases. And fossil fuel, on the other hand, produces unfavorable gases when burned. So such as methane and CO2. The thing about fossil biofuel is that it can be produced with safer method, and fossil fuels is produced from unsafe methods such as drilling or milling, which also is explores the earth inner core. So what is biorefinery? As the subject goes, biomass conversion and biorefinery. So biomass conversion, you have seen that what is this, that we to convert biomass into a type of energy. So what is biorefinery? Biorefinery is a renewable equivalent of a fossil based petroleum refinery. It is nothing just equivalent to fossil based refinery. It also produce biorefinery is a system, or you can say machine, a set of system machines that produces electricity, just as in case of fossil based refinery. Just the thing is that it biorefinery connects that those machines to the biomass to produce energy. So according to National Renewable Energy Laboratory, a biorefinery is a facility that integrates biomass conversion process and equipment to produce fuel, power, chemicals, from agriculture, forest, and waste feedstock. So, if we want to produce energy from biomass, we have to integrate those biomass with some processes and equipment. So, this facility, process, and equipment that connects the biomass to produce fuel is known as biorefinery. So, any question on this? Anyone? LPG natural gas है क्या? No questions on this biomass or conversion or what is biomass, what is biorefinery. So I guess everyone has no questions and okay. So I will move on to the now chats. Has anyone asked any question? Okay, so Sanjay Jahagirdar has one question. Is LPG considered as natural gas? See, the thing with LPG is it is petroleum gas, liquefied petroleum gas. So it's not a natural gas, it is a petroleum gas, a type of petrol. It is so major majorly LPG is propane gas. While LPG is produced, sorry, LPG is propane and natural gas is methane. So I will, if Sanjay is not here, so I will write the answer in the chat box also. That LPG is liquefied petroleum gas, not natural gas. But there is a connection between these two. LPG and petroleum gas both are nearly odorless. So in both the cylinders we add, oh sorry, in both the gases we add a compound which is known as mercaptan. Mercaptan has a sulfur like or rotten X smell. So to identify these gases, so both might smell same but are different because the smell is of mercaptan. Okay, okay. So anyone, if anyone wants to ask any question, you can. Okay, someone has her. I am a physicist. Zero knowledge of chemistry and botany. Okay, so okay, I will tell you in more plainer words. So the thing is, LPG is particularly propane, and propane. Just wait a minute. LPG is propane, And in this word propane, propane, this means three. So this contains three carbon. This gas has three carbons in it. If we go towards the chemical composition, and natural gas is methane, which is not three but has one carbon. So chemically both are different, and the sources are very much different, and both are based on fossil fuels. Both have same source, the crude. Both have the same source, but due to the difference in chemical structure, they have different densities. So they are obtained at different point of during the distillation process. Okay, okay. So anyone else? Any questions? So any questions? Anyone? Feel free to ask any question if you want. As this um, lecture is only for to make you able to solve the assignment questions. So if you have any kind of question related to your assignment one, you can ask anything or any other basic stuff related to biomass. Okay, then if anyone don't, so I will leave the meeting here, as nobody as everyone has cleared their doubts, and we'll meet you next week when we will be discussing about the assignment 2. Okay, someone said is a numerical question in the assignment how to solve. I don't think so that there is any numerical questions in the assignment, as not not in the assignment 1 particularly. It is just an introductory lecture, so everything is theoretically only. Okay, someone has asked, will you be uploading video recording? Yes, this video will be uploaded on the YouTube. You may see this video after one or two. You just search for the course code NOC23-ch33 week 1 assignment 1 on the YouTube after 1 or 2 days, and you will see the recording on the YouTube. Assignment to someone has asked for assignment. Okay, okay. So assignment 2 will be having numericals. Yes, I cannot help for assignment 2 now. I can only guide you for the assignment 1. The assignment 2 will be discussed in the next week. Okay, I hope you all have liked the session, and I will be leaving the meeting now. Thank you very much for your patience, and thank you for listening. I hope you have learned something. Thank